Hello students, myself Dr. Anupreeta Mishra and you are watching Anupreeta Mishra's Electrical Engineering. Today I am going to teach you the difference between the two types of the rotor constructions, that is salient pole rotor construction and non-salient pole rotor construction. Non-salient pole rotor construction is nothing but cylindrical rotor construction, known as cylindrical rotor construction. This particular part I am taking under synchronous machine construction, and one video I have already published regarding stator and stator frame. The next step I am going with rotor construction, as I said, salient pole rotor construction and smooth cylindrical rotor construction. Salient word means that something projected outside. Like here we have this rotor core. This is rotor core, and from here I am finding the projected poles over here. The projected poles are outside to the rotor core. So we construct rotor core first, and further we also construct number of poles separately, and then we pivot it there at their place over the periphery of the rotor core. This is known as saliency. Here, cylindrical rotor structure means we have a cylindrical rotor construction, solid rotor construction, over which we have the slots cut over it. Now, how many number of slots to be cut? So, number of slots are totally dependent on the periphery of this rotor, cylindrical rotor, because 2/3 of the periphery is covered with the slots cutting, and remaining non-slot cutting portion is made as north pole or south pole. How come we can achieve these north pole and south pole development? So that is totally dependent on the direction of the current flowing through the winding itself. And which winding? DC field winding. Here we have the windings which are being wrapped over these salient pole, and the winding is nothing but DC field winding, whose first positive polarities wire is being wrapped over this, then next over this, then next over this, and next over this, in such a manner that as soon as the current flows in this winding in this sense, so finger is showing the direction of the current, so thumb is giving me the direction of the flux, and if I am finding the direction of flux through this pole material outside, that means this is going to be working as north pole. Similarly here, if the flux lines are getting inside, the wrapping sense of my fingers is according to the flow of current of the winding, so it would be generating south pole here, and I made it in the same manner so that current flows like this, so the thumb is directed in the left side of the board, or I should say my right side of the board. So this becomes south pole, this becomes north pole, this becomes south pole. Already I have explained beta that the consecutive poles are always opposite poles and not the diametrically opposite placement of the poles having the different nature or opposite nature. Diametrically opposite may have the similar nature of the poles, but consecutive poles must be the opposite nature of the poles. That way we have to construct it. I have already published a video over this particular concept, that why consecutive poles are of opposite nature, that I have mentioned and explained everything over there. Now, as I said, I am wrapping the winding over here. So this is nothing but concentrated type of the winding, because we are having the turns simultaneously over the same position likewise. So this is concentrated one. So DC field excitation is given through this plus minus polarity, some DC voltage is there, and all these windings are in series and wrapped in a sense or in such a manner that north pole, south pole, north pole, south pole are being there generated, and this is positive polarity, current is flowing like this, and again we have the negative polarity of the wire over here. This way this particular connection is made. Here we have the concentrated field winding, here we have the distributed field winding. As I am showing here the 10 slots, and in 10 slots I am putting the winding DC field winding. So say positive polarity of the DC field winding is there, then I am keeping going on like this, wrapping the winding, and ultimately I am having the end of that winding through here. So this way the wrapping of the winding gives me the development of north pole and south pole over here. So this winding placement is known as distributed type of winding. Now, this salient pole structure is always utilized over low speed synchronous machines or low speed alternators. Low speed alternators are those which are being driven by the water pressure. That means water falls over the blades of the turbine, which turns the rotor itself of the alternator, and alternator would be catching up that speed which is given by the turbine itself. So that speed is low because it is driven by water pressure. So when low speed alternators are to be manufactured, so we try to make them salient pole structure, and if low speed is there, that means number of poles should be high. So in such salient pole structures, we would be having either 4-pole machine or 6-pole or 8-pole. Likewise, we don't follow 2-pole machine because 2-pole machine is the machine or alternator which is having the maximum speed, and these particular alternators which are having the rotor with salient poles, so these won't be of high speed. So certainly these alternators are of low speed, running by the water pressure, and they are having the poles 4 or more than 4 poles. These alternators are known as hydro generators. Similarly here, these particular alternators who are having say smooth cylindrical rotor structure, these are of high speed, and certainly high speed alternators are being run by the steam pressure. So the turbine is having the pressure of the steam through the jet. Those turbines consequently turns the rotor of the alternator. That rotor catches the highest speed because of the steam pressure, and these alternators are made up of smooth cylindrical structure. Now as speed is high, so the number of poles would be less. So these structures are made with either 2 poles or of 4 poles, and these are known as turbo alternators. So low speed generators are known as hydro generators, high speed generators are known as turbo generators. They are driven by water pressure, they are driven by steam pressure. Now, salient pole have concentrated winding, as I said, and it is having the distributed winding. Now, one more thing here, stator would be having the periphery like this. So this is ring type cross section of the stator, you can imagine over here. So you can find that in between stator and this pole tip, center of the pole tip, we would be having some small air gap, and biggest air gap is existing between the stator inner periphery and the in between the 2 poles. So here we have the non-uniform kind of air gap, and non-uniform kind of air gap is there. So we try to make it radially increasing. That means here at the center of the pole we keep lowest air gap, and radially that air gap is increasing till in between the poles. And that the purpose of this such kind of designing is this, that we need sinusoidal pattern of the flux in the air gap itself. That is the reason. So non-uniform air gap, but we try to achieve the sinusoidal air gap flux pattern that way by keeping this and increasing the air gap radially till the middle of the poles. Actually, here we have the uniform air gap, because if you imagine a stator periphery like this, so everywhere you will be finding the same air gap length. So as the air gap length is same or uniform air gap length is there is no variation of air gap. So here we find less noisy operation of the turbo generator, but here we may find noisy operation of the hydro generators. Now, as I said, more number of poles to be saliently arranged over this rotor core. So certainly diameter of this rotor core must be high. So for salient pole rotor structures, diameters are always large and axial length is always small. What do you mean by diameter? This is diameter and this is axial length. So we keep small axial length in case of salient pole, and that axial length is always kept perpendicular to the ground actually. So axis of the rotor is kept perpendicular to the ground. So in salient pole structures we have the large diameters and small axial length, and we keep it perpendicular, its axis is kept perpendicular to the surface, so they are vertically configured. This is known as vertical configuration. Here the poles are outside to this, so number of poles are more projected outside, so when it rotates, so more mechanical stresses are being developed inside it. So we keep a large diameter as well as small axial length to keep control over the mechanical stresses, as well as we put its axis vertical to the surface of the ground actually, so that less mechanical stresses should be there, less centrifugal forces would be affecting this structure. And also I can say that these particular structures are followed in low speed alternators. Why so? Because if you turn them with the high speed, so naturally mechanical stresses will affect this mechanical structure of the salient poles. So we deploy these structures in low speed actually. So here I wrote everything what I said. Here the diameter of the rotor is less, and axial length is large, because again centrifugal forces would not affect that much. And as the axial length is large, so we keep it horizontally configured, means axis of the rotor is kept parallel to the surface of the ground, so that again centrifugal forces or the mechanical stresses should not affect its operation and do not cause any large maintenance aspect into it. So all these things I have mentioned here, and hoping that you people have understood the difference between the salient pole rotor and cylindrical rotor structure, which is also known as non-salient pole rotor structure. But beyond this, whatever few things are being left, I'll cover in the next video. But right now, this difference type of tabular structure of this question, that what is the difference between the salient pole rotor and cylindrical rotor, that I have explained here in this pattern, and in the exam also you can write the answer in this pattern. So hoping that you people are liking the way I am teaching. So kindly do like my video. Please subscribe to my channel, and also convey your friends to subscribe my channel. And please achieve individual concept clearance through my videos, because I am deeply convincing with the concept what I am delivering through my videos, and certainly those would be convincing to you people also. So please do like my videos. Thank you.